quickly review for you about the Pythagorean theorem. The image that you see here on the first slide is a common image. I think it's the one that we're first introduced to a lot when we work with the Pythagorean theorem. And it's showing that the square of one of the legs, so here it's a length of 4, so 4 times 4 is 16, or 4 squared is 16. And the square of the other leg, and here this leg is 3, so 3 times 3, or 3 squared is 9, is equal to, so 16 plus 9 is equal to the square of the hypotenuse. That's always the longest side, or the side that's opposite the right angle. Here the hypotenuse 1, 2, 3, 4, 5. 5 squared is 25. So 16 plus 9 is equal to 25. And so this whole relationship here between the squares of the two legs of a right angle triangle and the hypotenuse is what we call the Pythagorean theorem. And we use this formula, a squared plus b squared equals c squared, to represent that theorem. The actual theorem itself is stated something like, in a right angled triangle, the square of the hypotenuse, so that's the third side, is equal to the sum of the squares of the other two sides. And I put this in the wrong spot. This 8 belongs down here, I'm sorry. So if we use the theorem, a squared plus b squared equals c squared, and apply it to this situation, we want to know what is the hypotenuse. Okay, then we take the length of the legs, 4, and we're going to square that. We're going to take the length here, 8, and we're going to square that, and we're going to see, is that equal to c squared? What is that? Well, 4 squared is 16, 8 squared is 64. 16 plus 64, we have, whoops, it's going to be 80. Now that's what c squared is equal to, okay? So in order to get just the c by itself, we're going to take the square root of that to see just what c is equal to. So the square root of 80 is 8.9. And I do want to keep the decimal, okay? We're not going to be rounding these to whole numbers. So 8.9. Great. That's if you have the two lengths of the legs. The other way that we use the Pythagorean theorem is if we have one of the legs and the hypotenuse. So if we start again, a squared plus b squared is equal to c squared. I have a leg and the hypotenuse. I don't necessarily have to say b squared. So what I want to do is minus the a squared from both sides. I'm just setting up a formula here so that to find a leg, I'm going to take the hypotenuse squared, subtract one of the legs squared. And it doesn't matter which is a or b. So in this case, when I'm missing a leg, I'm going to subtract. When missing a leg, wow, leg only has one G, I don't know why I put an E on there. Leg, you must subtract. I'm missing a leg, subtract. Okay, so I don't know what b squared is, but I know that c squared is going to be 9.9 squared minus 6.5 squared. Well, 9.9 squared is 98.01, and 6.5 squared is 42.25. So this all works out to be 55.76, and that's what b squared is. So remember, just like before, we have to take the square root at the end. So the square root of that previous answer is 7.4. I'm going to round that to a 7. 7.47. So first example, we have two legs, we're finding the hypotenuse, so add. Second example, we have a leg and a hypotenuse, so subtract to find that third leg. The last example, is this a right triangle? Since we know, again, a squared plus b squared is supposed to equal c squared, if we have three sides but don't know if it's a triangle, then the relationship should work. Is 6 squared plus 8 squared equal to 9 squared? Well, that's 36 plus 64. Is that equal to 81? 36 plus 64, well, that's 100. That's not equal to 81. Not equal, so the equal sign with a dash through it. So, since the relationship did not work, we would say no. This is not a right triangle. If the relationship did work out to be true, say this was 10, so 100 is equal to 100, then we say yes, it is a right triangle. That's it, pretty straightforward. Hopefully review. We'll practice this in class.